Yes. Good morning, children. Today we are going to discuss about the continuation of this binomial expansion. We have already learned part of this binomial expansion, and today we are going to extend from the topic where we have learned from yesterday. Right. So, if you just have a little bit of a brief on the sections where we did with the binomial expansion, we already came to know that. Ordinary binomial expansion where we have already learned in our AS level is only applicable for positive integers, just like this kind of situation. But you cannot apply the same formula for fractional powers and the negative powers, such this kind of situation. In this situation, we just learn some kind of formula called universal binomial expansion, which is applicable for all positive, negative, and fractional figures. So that is why we were already learning the last topic. But when you're learning about this formula, I just highlight one kind of a point. Here, this universal binomial expansion is relevant for 1 plus ax to the power n type of formulas. But if this is not one, how do we supposed to deal that kind of situation? That is a question where we have to discuss in today's topic. Right, let's go ahead. Yeah. Right. Then today's our topic is to learn about how to do the binomial expansion for a plus bx to the power n. A plus bx to the power n formats. Right. Okay. Let's try to discuss this matter from a single example itself. That would be kind of convenience for you to understand the situation. For example, if you want to get 4 plus 3x to the power half. Right. This is pretty simple. What you need to do is, anyway, if I make this number by 1, you can apply into the previous formula where we have to do it. So I just write it as expansion. Right. The simple way of doing this question is you can just take 4 out from this x bracket. 4, if you take 4 out, this is turned up to 1 plus this term turn up into 3 over 4. That is pretty simple. You can understand the situation. So you can say 4 into 1 is 4. 4 into 3 over 4 is that one also 3. So to the power half. Then you can write this is 4 to the power half and 1 plus 3 over 4 x to the power half. That's a fact where we have to understand, right? Now you need to understand that this 4 to the power half is 2. 4 to the power half is 2. Then we can apply, you can understand that 4 to the power half is square root of 4, that is 2, times of 1 plus 3 over 4 x to the power half. Now you can apply the universal binomial expansion for this part of it. So you can say it's turned up to 2 times of, you can say 1 plus n times of 3 over 4x divided by factorial 1 plus the next one is n minus 1. Then you can say this is 3 over 4 x to the power 2 divide by factorial 2, right? We'll write another term as well. Then you can say n is, so here with this, you can say this is n is half, n minus 1, n minus 2, that is minus 3 over 2. So n is half, half minus 1 is minus half minus 2, 3 over 2. Divide by 3 over 4 x to the power 3 divide by factorial 3. Right, like that it goes on till the infinite series, right? Okay. Then you can work out this way. It's turn up to 2, 1 plus operation of this is 3 over 8 x. And if you operate this is turn up to minus, so you can just work out half into minus half into 3 over 4 squared, that is 9 over 16. 9 over 16, that answer has to be divided by factorial 2. Answer is 9 over 128 minus 9 over 128. 1 28 x to the power 2. Right? Okay. Then if you operate this, so it's turn up to half into minus half into minus 1.5 into 3 over 4 cube. 3 over 4 cube is 27 over 64. 3 cube is 27, 4 cube is 64, 3 over, so 27 over 64. That answer divided by factorial 3. Answer become 27 over 1024. It's a plus value. Plus 27 over 1024 x to the power 3. Right. Plus it goes to the as an infinite series. So this is turned up to 2 plus 3 over 4x minus 9 over 64 x to the power 2 plus 27 over 512 x to the power 3. It goes to a as an infinite series. That is the way of working out this kind of a question. I just little bit of a make it small, then you can see the full question at once. So this would be your final answer. Right. Let's go ahead with little bit extends the question. So this is the way they have given some kind of a expression. Yeah. So that is how it comes. Right. Okay. Hope you can understand how it came. Right. Okay. Then like we'll try to work out this kind of situation. 1 over 2 plus 3x to the power 2. That is the next question. 1 over 2 plus 3x to the power 2. Right. Okay. Then you can say this is it's much easier for me. Then it's turn up to 2 plus 3x to the power minus 2. So what you need to do as usual, we have to take 2 out from this expression. It's turn up to 1 plus 3 over 2x, all thing to the power minus 2. This is pretty simple. Then this is turn up to 2 to the power minus 2 times of 1 plus 3 over 2 x to the power minus 2. So we know that 2 to the power minus 2 is how much? Just to calculate and see whether it's 1 over 4. 1 plus 3 over 2 x to the power minus 2. Then simply you can apply binomial expansion, universal binomial expansion for this part, keeping 1 over 4 out. It's turn up to 1 plus n x. X is 3 over 2 x over factorial 1. Then n minus 1. Then 3 over 2 x to the power 2 over factorial 2. Then n minus 1, n minus 2, 3 over 2 x to the power 3 over factorial 3. Hope you can understand how I get this the factorial parts. Not the sorry, the term. N is minus 2 over here, so it's n minus 1 is minus 2, minus 1 is minus 3, n is minus 2, n minus 1 is minus 3, n minus 2 is minus 2 minus 2 is minus 4. That's how it comes, right? Okay. Yeah, let's try to expand this. Right, if you do this, you can say it's 1 over 4. If you operate this, is turn up to 1 minus 3x. Then this is turn up to minus 2, minus 2 into minus 3. That is 6 into 3 over 2. 3 over 2. This answer must be divided by 2. So the answer is 9 over 2. This is turn up to plus 9 over 2 x squared. Then the next one is minus 2 into minus 3 into minus 4 into 3 over 2. Yeah, 3 over 2 cube. 3 over 2 cube is 27 over 8 divided by 6. That answer is minus 27 over 2. Minus 27 over 2 x to the power 3. It goes to as an infinite series. Yeah. Then yes, hopefully just check with this answer over here. We will just recheck this answer. That is minus 2 into minus 3 into 9 over 4. 4 divided by 2. That is 27 over 4. I think we made a mistake. Here this value should be not 9 over 2. I think it's just I didn't square this figure seems to be. This value should be 27 over 4. So please make it correct. This is 27 over 4. Right, okay. Then let's what you need to do. You have to expand the brackets. So you can say it's 1 over 4 minus 3 over 4x plus 27 over 16 x to the power 2 minus 27 over 8 x to the power 3. It goes on somewhere like this. That's a way of doing this kind of a question. Hope you can understand how we did that kind of situation. Right? That is the way of doing it. Right. Then we will come up to the convergence series later on, little bit later. Right. So this is the way you can do any kind of situations just like this. Right. Okay. Yeah. Right. Okay. Then we will come up with the yeah. If you happen to work out this kind of question, 1 over x over 2, 2 over x. Yeah. This is if you happen to see 1 over x over 2 over x. Actually, this bracket is not required. I just, by mistake, I wrote it. This is not required. Right, okay. Then for this kind of situation, you can say this is 1 plus x into, this one you can write 2 plus x to the power minus 1. I just brought it up and wrote it as a minus power. Here there is no need of doing any binomial expansions if the power is 1. Only for this bit you have to work out, and later on just multiply with 1 over x. So I'll just get it as 2 plus x to the power minus 1. Okay. That is, you can say, you can take 2 out, 1 plus half x. When you take 2 out, 2 into 1 is 2, 2 into half is that, to the power minus 1. So this is turned up to 2 to the power minus 1. That is 1 plus half x to the power minus 1. 2 to the power half is 1 over 2, 1 plus half x to the power minus 1. Right. Then we will do the expansion for this. So you can say this is half. We'll do this expansion. 1 plus n minus 1 x. That is half x to the power divided by factorial 1. Then n minus 1. Then half x to the power 2 over factorial 2. Right. n minus 1, n minus 2, half x to the power 3 over factorial 3. Usually we can write any much of terms, but usually we write 3 terms. It goes further. It's an infinite series. So that one you have to keep it in your mind. So this is half. You can say this is 1 minus 1 over 2x. Then this is turned up to plus. If you simplify this, minus this 2 get cancels over here, and it's turned up to 1 over 4x squared. 1 over 4x squared. Then this is turned up to minus 1 over 8 x to the power 3. So you just expand and see, you will understand how it came, right? Okay. Then this answer become 1 over 2 minus 1 over 4x plus 1 over 8 x to the power 2 minus 1 over 16 x to the power 3. Like that it goes on, right? This is the expansion for this bit. There is another part at the top. We have to do this 1 plus x into that expansion. Then you can write the final answer become 1 plus x times of this bit. 1 over 2 minus 1 over 4x. Sorry, 1 over 4x plus 1 over 8 x to the power 2 minus 1 over 16 x to the power 3. Goes on, right? Okay. Then if you just do this expansion. So initially I just multiply everything with 1, therefore you get the same expression. So I just write 1 over 2 minus 1 over 4x plus 1 over 8 x to the power 2 minus 1 over 16 x to the power 3, so on. Right, then I'll multiply with x. X into half is half x. Then I write it below this. It's easier for me to calculate. That's why I'm just writing 1 below next. I think yesterday also we used the same technique. X into minus 1 over 4x is minus 1 over 4 x to the power 2. X into 1 over 8x is plus 1 over 8x cube. Then x into this is minus 1 over 16 x to the power 4. Right? Okay. Then you can get this answer. Right. Then if you just do this, it's done up to 1 over 2. Minus 1 over 4 plus 1 over 2 is 1 over 4 x. 1 over 8 minus this is minus 1 over 8 x squared plus 1 over 16 x to the power 3 minus 1 over 16 x to the power 4. Yeah, that's it. It comes like that. So that is the way of getting this answer, right? So hopefully you can understand how we did this kind of a question. So you should be able to do this kind of situation as well. Yes. Then, yeah, the same technique you can apply for the rest of it. Yeah. Then they mention fx is 5 plus x to the power minus 2. This boundary condition later on I'll explain at the next video. Find the binomial expansion of fx ascending power of x up and including the terms x to the power 3. That is a usual concept they mention. Up to which level we should write it. So you can just do the expansion as what we did. So over here you can take 5 out and that one 5 to power minus 2, same technique we use. Let's go ahead with this bit. There is another important question where we are supposed to understand, right? Mx is 4 minus x to the power half square root. Find the series of the expansion ascending power of x up and include the term of x to the power 2. So you need to writing up to x to the power 2. Let's see, 4 minus x. So initially we just work out over here. I'll just in front new page. This is 4 minus x the square root of it. This is turned up to 4 minus x to the power half. Same technique I'm using. Sorry, you can take 4 out. 1 minus 1 over 4x. All thing to the power half. That is turned up to 4 to the power half times of 1 minus 1 over 4x to the power half. Then we know that 4 to the power half is 2. 1 minus 1 over 4 x to the power half, right? Okay. Then 4 to the power half is 2. You can understand how it came, right? Okay. Then let's go to the expansion for this. So turn up to 2, 1 plus n. N is half. X is 1 over 4x to the power divided by factorial 1. Then n minus 1, 1 over 4x to the power 2 over factorial 2. Then the next one is n minus 1, n minus 2 into, sorry, no need of writing at x to the power 3. The reason is that they ask you to write only up to x to the power 2. Because we need that expression only. So therefore, no need of writing this term. So anyway, it goes to the infinity. Therefore, we have to just put some addition and just do this expansion over here. So this is turned up to 2. 1 plus 1 over 8 x to x, right? Over here it's turned up to 1 over 2 into minus 1 over 2 into 1 over 4 squared is 1 over 16. That answer divided by factorial 2. That is minus 100 and yes, minus 1 over 128 x to the power 2. So the expansion become 2 plus 1 over 4x minus 1 over 64x squared. That is the answer for that. It goes to the infinity. You just write over here. Now let's see what kind of next situation they request us. Right. Then they mention show that x equals to 1 over 9 to find the exact value. Sorry, show that x equals to 1 over 9. The exact value of mx is 35 over 3. So simply what you need to do is you can substitute this 1 over 9 into this and show that it come up to this one. Right. Okay. Then you can say, yeah, 4 minus x. So the part B is, yeah. So part B answer is, you can say 4 minus x the square root. Then we will put 1 over 9 over here. 4 minus 1 over 9. What was that answer? That answer is 35 over 9. The square root of it, that is root 35 over 3 would be the answer for that. That is what they expect, right? Yeah, that's what, right. Then what you need to do is use the answer in part A to find the approximated answer for root 35. Calculate the percentage error, right? Then we know that here the expansion for this is this, right? Therefore, here when you substitute 1 over 9 into this, you get this answer. That means by substituting 1 over 9 into this x, you get approximated answer for this. That is the logic we use with it. So C, we know that, you can say 4 minus x, the square root is equals to 2 plus 1 over 4x minus 1 over 64 x to the power 2. Right? Okay. Then you substitute 1 over 9 into this. Square root is equals to 2 plus 1 over 4 into 1 over 9 minus 1 over 64 into 1 over 9 whole thing squared. Right. Then at this substitution, we already found this answer is similar to how much? Root 35 over 3 is equals to, if you operate this part of it, it's turn up to 2 plus 1 over 4 into 1 over 9. That is 1 over 36. Minus, this is turn up to 1 over 64 into, that is turn up to, this answer become 10,511 over 5,184. Therefore, to 35 you can say 10,511 divided by 5,184 into 3 into 3. With this answer you can say root 35 is equals to 10,511 divided by 1,728, or you can just write the answer, that is so it's turn up to 6.0827. This is approximately like a little bit of a extrapolation means some kind of a little bit of overestimation, but actual speaking, so you can say the percentage error. We know that actual value for square root of 35 is this bit. Actual value for square root of 35 is 5.916. 5.916. That is the actual value minus the error. Error is we got into as 6.0827 divided by the actual value. Percentage error is the error. Error is the actual value minus the approximated answer divided by the actual value. 916 into 100%. I think you have already learned this one in physics as well. How to find this? Actual value minus the approximated value divided by the actual value, right? So if you just work out 5.916 minus 6.0827 divided by 5.916 into 100. You get a percentage error as minus 2.818. Minus 2.818%. This much of an error percentage you can see in this kind of a question. So that is a way of doing that kind of situation.